200 out of 100 students would have problem with this formula. Yeah, you had that right. 200 out of 100 students would have problem with this formula. And what is the name of it? It's called the mirror formula. So how do you really figure it out, especially because of the signs and everything? Calm down, let me explain. Shout out to Online Backer, by the way. So this is how you address the mirror formula properly. Now I've put these two images so that whichever one is used to denote it in your school, you'll be able to. Now, but I will be sticking with U and V. Now this one, D naught and DI, they represent the object distance and the image distance respectively as well. So let me stick with U and V. Now for this, now you have to know that we have two different type of mirrors. We have the concave mirror, we have the convex mirror. I mean, two types of curved mirrors, concave and convex, because we have plane mirror as well. Now, for the concave mirror, which is the one that is coated on this end, and then we have the convex mirror as well, which is the one that is coated on this side. Now, the first thing to take note is that F is always positive for this one, and for the convex mirror, F is always negative. I mean, anytime you are given F, once you want to insert it into this mirror formula, you must take a positive sign for F for a concave mirror at all points, and for the convex mirror, it must take a negative value at all time. Now the next one is U. U is the object distance, which is, you know, our guy in the first place. So that one should not be negative. So it is going to be positive. Now, so what now happen is that for your V, if it was not outrightly mentioned that your object is your image produced is a virtual image, then you would be confused as to which sign would you use. But if it is mentioned that your V is a virtual image, which is what convex mirror would always produce. So for convex mirror, your V is always going to be negative. Always going to be negative. However, for the concave mirror, there's a particular point in time where you have a virtual image, which you might not be doing. And that is always when the object distance is lesser than the focal length. That is always when you have a virtual image. But let's say you are given now. So how do you now go about it? Now, if you are given F and you are given U, and you are asked to find V, just use these two signs that I've given you here. Put it here. When you finally solve your problem, you will see that V is going to give you, whether it's going to be positive one or it's going to be a negative one, you are going to definitely get your result. So you don't need to bother about, oh, is it a virtual image? What sign is it going to take? You don't need to bother about that. For concave mirror, you don't really need to stress yourself that much. Just use that. And for the convex mirror, it stands sure. This takes some attributes with God. It stands sure. This F is always going to be negative and V is always going to be negative. When you are using this formula, I'm repeating it. Just insert them with the signs like that inside this formula like that, and you would be fine. And that's how you use the mirror formula. This also applies when you are taking into consideration lenses. However, you have to be able to take note that convex lens is the converging one and concave lens is the diverging one, and you have to be able to take note of the difference between what a virtual image is when you are using lens and what a real image is when you are using the lens. So that is how you use the mirror formula correctly. If you like this video and you want to see more videos like this, follow me and subscribe. I'll see you in the next one.